In this section, we want to look at using Desmos to find Extrema. Keep in mind that Extrema is a more general term, a way of saying we want to find any maximum or minimum values that may occur. And we can identify those by looking for points where our function changes directions. As an example, with the function that I've sketched out here, we see that it changes from increasing to decreasing, meaning at the top of this peak we would have a maximum point. Our function is decreasing and then changes to increasing, meaning at the bottom of this valley we would have a local minimum. So when we graph functions, what we're doing is looking for those changes in direction from increasing to decreasing, or vice versa. In examples 1 and 2, we're given two different functions and specific domains that we want to consider. In example 1, if we switch over to Desmos, we can start graphing and type in this function, f of x equals x cubed minus 5x plus 3. And then we can use the wrench icon, the plus and minus buttons, or the scroll wheel on your mouse to adjust the view for our window. We're looking at anything occurring between x equals -2 and +2, and we can see that in that domain we have two different extrema, a maximum and a minimum point. In order to identify those, we simply have to click on our graph, and we'll see a few different points in gray get highlighted. I'll actually switch this over to projector mode so that's a little bolder. So if we click on our graph, we'll see those points, and by hovering over those, we can get those x and y coordinates for those 2 points. So our local maximum is occurring at x equals -1.291, and our minimum is occurring at x equals 1.291. Depending on how we're asked in a question to report that answer, we may be looking at identifying just the x value or the xy pair that correspond to that point. But once we have the x values identified, then a further question that we can answer is looking at defining, using interval notation, where our function is increasing or decreasing. In this case, we can see that from -2 until we reach that maximum, our function is increasing because it's going up as we read the graph from left to right. Then it changes to decreasing since that curve is headed down, and then at that local minimum, changes to increasing again up until we hit x equals 2. Obviously that behavior continues on past that point, but for this particular problem we're only looking at that interval from -2 to 2. So we could say that our function is increasing on the interval from -2 to -1.291, and then use that union symbol to identify the second interval where it's increasing, which would be from x equals 1.291 to 2. Again, we're stopping our intervals at -2 and 2 since we are given this specific domain restriction. We can also identify where our function is decreasing by indicating those x values in -1.291 to +1.291. In example 2, we're asked to do essentially the same thing, we just have a different function to consider. So we can delete that first graph and type in our new function. And again, adjust our viewing window until we can see the maximums, any maximums and minimums, so any extrema that occur on this interval from -6 to 4. In this case, we again have 2. We have a minimum occurring at x equals -2.052 and a maximum occurring at x equals 1.218. So we can identify that local minimum as occurring at negative 2.052, comma negative 9.805. And we have that local maximum occurring at x equals 1.218, y equals negative 2.811. In this case, we could refer to our function as increasing on the interval from negative 2.052 to x equals 1.218. And we'll have two different intervals on which it's decreasing, which would be from negative 6 to negative 2.052, and from 1.218 to x equals 4. Again, in this case, we're stopping our interval at negative 6 and at 4, since we were given this specific domain restriction, this specific interval to consider our function. So what we're looking at then is just from negative 6 to positive 4, what the behavior of our function is, using the maximum and minimum points, or I should flip that around, using the minimum and maximum points that we identified along the way as those turning points where our function changes directions between increasing and decreasing.